Welcome to our latest Graham Sibbald Podcast episode. Today we are joined by Andy Thomson, who is a partner and head of Glasgow Building Surveying at Graham Sibbald, based within the firm's Glasgow office. Hey Andy, how are you?
Hi Jorja, I'm good, thanks. How are you?
Yeah, I'm good, thank you. Thanks for joining us on the pod today.
You're welcome.
So, as always on the podcast, we kind of start with getting whoever is on to explain their role within Graham Sibbald. So, tell us what you do at Glasgow.
Cool. Well, as you said, I'm head of building surveying based in Glasgow office here. I've been at GNS for over 11 years now, and alongside the team, I work with a broad spectrum of clients in both the public and the private sectors and provide all traditional core building surveying services, including contract administration, the LAPs, a full range of building surveys, including technical inspections, pre-acquisition surveys, schedules of conditions, and many more.
Cool, that sounds interesting. So, on today's episode, we are talking about a specific type of concrete, which is Reinforced Autoclaved Aerated Concrete, or RAAC for short. It's a concrete that can cause some problems, which we'll get to shortly. But first, what exactly is it and where is it used?
Well, I'm sure most people will have at least heard of RAAC now due to the recent press coverage. And we at Graham and Sibbald have been undertaking surveys identifying RAAC for some time now, with it being a key issue within the construction industry even before it hit the news. So, what is RAAC? Well, RAAC is an acronym for Reinforced Autoclaved Aerated Concrete, and it's an aerated, lightweight, cementitious material with no coarse aggregate, which is generally formed in planks or panels and mostly used in the construction of structural roof decks. The panels are constructed in factories with the concrete mix being provided with steel reinforcement bars, and chemicals are then added to create gas bubbles within the concrete, which gives it its kind of aero chocolate bar type look. The materials, properties, and structural behaviour of the RAAC differs significantly from traditional reinforced concrete. That's mainly due to the fact that it is no coarse aggregate and uses only fine aggregates. So instead of having big stones in the mix, it's only got really fine, kind of sand-like materials. Now, tens and thousands of these structural panels exist across a broad section of buildings, mainly constructed within the 1960s and 70s. RAAC elements are not thought to have been incorporated into buildings in the prior to the late 50s or in significant quantities into the 80s. However, there are examples of buildings constructed in the 1990s that have been found to contain certain RAAC elements, which potentially then increases the scope of buildings that could require surveyed in order to determine the presence of a RAAC. So the vast majority form the structure of a flat roof deck, and therefore generally difficult to access, survey, maintain, and replace. Now, buildings of that era that have not been adequately maintained are of the main concern, especially when you consider that, as I mentioned previously, the estimated lifespan's 30 years. So in all instances, their life expectancy is deemed to have expired already. RAAC, however, is still manufactured and is installed all over the world and can be an appropriate construction material if properly designed, manufactured, installed, and maintained. Now, it's predominantly used in large-scale public buildings such as schools and hospitals. And the precast nature of the panels, along with their light weight, vastly sped up the build time. They're also fire resistant and have good thermal properties, and as such, it was a popular choice at the time.
So, you mentioned the concrete is used in public buildings such as schools and hospitals with a lifespan of around 30 years. But there are some issues with the concrete. So, what are the problems associated with the use of RAAC?
Well, as I said before, the makeup of the concrete panels differs significantly from traditional reinforced concrete panels, and that's due to the lack of the coarse aggregate. And that's got two key effects on the panel. Firstly, it reduces the weight of the panel significantly, so it's approximately 20 to 30% of the weight of a standard reinforced concrete panel. But secondly, it also reduces the strength of the panel by a similar ratio, and that combined with some other key factors leaves the panels liable to sudden and complete failure, as has happened in a couple of instances. Now, these issues can generally be split into three main groups. So it'd be manufacturing defects, construction and workmanship damage, and performance defects. And I'll just briefly run through the main issues with each of these different areas just now. So firstly, manufacturing defects. A main issue is the misplaced transverse reinforcement. So the reinforcement within these panels relies on two areas for its strength. It's got the longitudinal steel, which runs the full length of that long rectangular concrete panel, You've also got this transverse steel, which effectively ties the length of that longitudinal steel together at each side of the panel, and it spans the width of the panel. And these two sets of bars are welded together, which provide tension to the reinforcement and therefore provide it with its strength. And that means that the workmanship by the manufacturer with the placement of the reinforcement is critical to the structural performance of the installed panel. Now, in some instances, it's been noted that the end of that longitudinal section and the position of that transverse reinforcement is terminated short of the bearing. The bearings that support that the panel's sitting on, and that could greatly affect the strength and capacity of that panel. So the number of transverse bars and the position of the reinforcement has also been found to vary from panel to panel, even within the same building. And another key factor is that steel reinforcement is located too close to the face of the panel, and that combined with the permeability of the panels, as I said, it's got that aerated nature, which makes it extremely vulnerable to water penetrating through it, means that the steel is particularly liable to corrosion if there is water there. Now, the next heading I mentioned was construction and workmanship damage. So a major issue with the installation of these panels is that short bearing length. Regulations at the time of the install required only 45 millimeters of bearing on the steel or concrete supports. Now, that's very small and a short length, and it vastly increased the vulnerability to misplaced reinforcement at the time of manufacture, and therefore results in that transverse bar not sitting over the bearing edge. So the latest guidance now states that that should be no less than 75 millimeters. Also, the cutting of components was known to have occurred where panels were made to a certain length. However, they were subsequently cut on site prior to the installation to suit the specific individual building constraints. Now, that could give rise again to locations where that transverse anchorage bar isn't in place over a bearing section. Also, structurally damaged building works is also a major issue. Many instances have been found where the many instances have been found where building refurbishment has resulted in builders' works holes through panels and therefore reducing strength by alarming amounts. Penetrations at the time of construction were often found to have straps off the adjacent panels or individual independent support timbers. However, even then, with that cutting and that transverse reinforcement, there's no guarantee that there's no risk of failure. And the final area of concern I mentioned was regarding performance failings with our panels. So overloading can be an issue. Due to the limited strength of these panels, they're not designed to hold any great weight. They were primarily used for a roof structure, and as such, there isn't often too much above them. However, if you've got over the life of a building, if new items of plant are provided to that roof, that could end up in result in stresses of that panel and potentially lead to failure. You've also got to consider natural deflection of these panels. That's where the panels may just naturally deflect and sag over their serviceable life, and that could also result in water ponding to the roof, which again would add to the loading with extra weight on top of these panels and potentially overstress the panels and again lead to collapse. Now, finally, and I kind of mentioned it before, prolonged water ingress due to the failure of waterproofing membranes is a major issue. Roof leaks in old flat roofs, as I'm sure you know, is not uncommon and can lead to corrosion of that reinforcement due to the aerated nature. You could also get water ingress through services failure or by interstitial condensation as well.
Okay, so a few vulnerabilities there. So if someone is listening to this and suspects that they have RAAC in their building, what exactly should they do?
So if you suspect that you've got a RAAC in one of your buildings or want to confirm that there is none, then the first step would be appoint a chartered surveyor. Now, Graham and Sibbald have got quite a few of these, and we get in there and undertake an inspection. Now, the inspection may need to be disruptive in order to fully confirm or rule out that you've got RAAC, and that will depend on the individual building constraints. It's something we're regularly now being asked to do on behalf of many of our existing clients and also quite a few new ones, as they need to be sure that the properties do not have RAAC. And if they do, then it allows them to look into their options.
So you mentioned the survey is dependent on kind of the individual properties and the restraints of the property, but how would a surveyor go about identifying if a building has been built with RAAC?
Well, there's various things that a surveyor would look for in order to identify if RAAC's present. So firstly, the RAAC panels, as I mentioned earlier, they're used mostly in flat roofs, but they can also be found in pitched or sloping roofs. And the easiest way, therefore, to identify RAAC panels is to look to underside of the roof. However, they may be hidden over suspended ceilings or plasterboard lined ceilings, and that could involve some lifting of tiles or disruption of finishes. The rack panels typically span between the steel or concrete beams, however, can also span onto masonry walls. As I mentioned, they're rectangular in cross section and they've got these chamfered edges, which, when two panels are sitting next to each other, give a V-shaped groove appearance. Also, the colour varies from white to pale grey. In terms of sizes, the standard width's 600 millimetres, however, they do come in anything between 300 and 750 mil. Thickness, they can be anywhere between 100 and 250 millimetres, and in lengths they vary, but the most common will be about 2.4 metres, however, they can span up to 6 metres long. The main determining factor, however, is that the surface is slightly crumbly when touched, unless it's been heavily painted or coated, and it feels softer when tapped with a hammer. It's easy to make a gouge with a screwdriver. Visually as well, if there's any sections where bits have broken away, that bubbly aero bar type appearance will be evident.
So if a surveyor has gone out from GNS to a property and RAAC is identified within the building, what are the next steps?
So if the presence of RAAC is confirmed in your property, then a structural engineer should be appointed in order to determine the condition of the panels and advise if any remedial works are required. Now, in general, it's been observed that there's a high degree of variability between panels, even where they were part of the same contract and installed immediately next to each other. Therefore, caution should be taken when assessing the results from discrete sampling. Now, dependent on the condition of these panels, the structural engineer may recommend full-scale replacement or just replacement or remedial works to individual panels. However, it's likely that until any of that happens, a regular monitoring procedure will require to be adopted in order to determine any change or deterioration in their condition. The frequency of that inspection will be determined by the structural engineer once he's done his initial inspection.
Great, thank you, Andy. Thanks for all the information on RAAC and what people do, what people need to do in their next steps. I think that's all we have time for today.
Cool. Thanks, Jorja.
Thanks, bye.
Bye.
For more information and to view the full range of services offered by the Graham Sibbald Technical Services team in relation to building surveying, please visit our website at www.g-s.co.uk. Thank you for listening. Until next time, you can catch up on all our latest podcast episodes via the playlist on our YouTube channel. See you there.